Hello, everyone. I was on mute there. My name is Chris Headley, and I'm the School Director of Teaching and Learning at the School of Computer Science at the University of Lincoln. Today, I'm going to be giving a talk on virtual reality and specifically movement and how we move through virtual reality. And this talk is called Gliding Through the Matrix Movement Modality in Virtual Reality. So hopefully everyone's seen the film The Matrix. If not, the statement might not make the most sense. But in the film The Matrix, people are plugged into a virtual world. They have freedom to move around, do kung fu, or even fly between buildings. Now, we're not quite at that level of technical implementation, but we are starting to experiment with virtual worlds in virtual reality. And movement is a major challenge there. So how do we move in VR? Now, there's various ways that we technically move. Now, you're probably familiar with one of these things, a gamepad. This is the most traditional form of control in video games. And it's really good because it allows really quite a unique and full freedom of movement. So if you've used one of these before, you have two joysticks, essentially. We have one on the top and one slightly lower down on the right. And you've also got a control pad joystick. So you can have quite continuous movement along a few axes. And what we tend to use these for is we use one control joystick for walking, for example, and another one for looking around. So if you've ever played an FPS game, you'll be used to that control schema. These are really good because they are adaptable, they're configurable, we can apply them to a whole range of different applications. We can pick one of these up, we can steer a car with it. We can also take one of these and fly a jet, fly a helicopter, like I say, walk around in a first-person viewpoint. Now, when we first came along to virtual reality, we made huge use of gamepads because they were what we had. So from a commercial VR perspective, they were really, really useful. But we quickly stopped using them. And this is largely due to cyber sickness. So for anybody who's ever been in VR, extended periods in VR can give you a feeling of, we call it cyber sickness, but it's very similar to motion sickness. If you've ever been travel sick, if you've ever been car sick, it's a very similar sensation. So as you move through the virtual space, the motion itself makes you feel on. There's a whole host of theories of why that is. But one of the reasons was you're not actually moving. You're not physically moving. You are seeing movement through your eyes in the virtual space, but you're not feeling it in your body. We have a whole bunch of sensors in our body that tell us when we're moving. If you close your eyes now and rocked or swayed, you can feel that motion. If you're driving in a car, if you close your eyes, you will still be able to be aware when the car is going forward, when it's going backwards, when it's turning. You'll feel the inertia, you'll feel the momentum. In virtual reality, you don't get those sensors actuated. Now with the control stick, suddenly we had that motion. We were moving in the virtual space, but we weren't feeling anything in our body. And also because of the way that we move with the control stick, the speeds that we expect them, the accelerations, there was challenges there into how it actually worked. So we moved on from gamepads relatively quick. And we then have what we call representational controllers. These are a slightly different class of controller. They're designed to resemble a real-world control interface. So you might have seen these. You might have had a joystick or a steering wheel. I very recently saw a control interface which was actually a set of wings that you could flap, and that would give you a feeling of flight. So these designed to resemble and feel like a real-world control interface. They are less adaptable because it feels wrong. You know, you could, in theory, use a steering wheel and some pedals to control a character's movement, to control a person's movement in virtual reality. But it feels weird to be literally driving a person. Joysticks, again, they feel really good when working with things like jets and helicopters and planes, that kind of thing that normally uses a joystick, but take them outside of that environment and they feel weird. So they can be very suited to very specific applications. So there's also been some argument that people feel ever so slightly less cyber sick when using this type of interface. There's a whole host of, and there's not a lot of research that supports this, but there is some going on at the moment. And there's some evidence that you are more willing to commit yourself to the belief that you are in the virtual world because you are holding on things that feel like they belong there. So if you're flying your virtual plane, you look down, you see a virtual joystick, and you are currently in the physical world holding a physical joystick. So your brain kind of connects the two and goes, okay, I kind of accept this new reality. Again, that's all hypothetical. The research is going on there, but there is some, there's some arguments, especially from user surveys. And again, if you're interested, you look at the comment section on things like on Steam games when they're sold. There's some arguments that some people believe representational controllers make them feel less cyber sick in certain games. And again, that is if the representation matches what they're doing in the virtual space. So a joystick for a plane, a steering wheel for a car. Motion controllers. These are I would say, the current gold standard of control in virtual space. And what we do, and I've actually got one hung up. I swear I'm prepared. I thought I'd already got this down. So motion control looks a little bit like this. We put it on our hand, and we can use it to track the motion of our hands. So you can't see it here, but I've got two little sensors on my desk, and as I move this to the right, it detects that my hand has moved to the right. As I move this to the left, it detects that my hand has moved to the left. Now, these are really great because suddenly I can do more complex movements. I can use my hands in the virtual world. I can reach out. I can grab things. I can, for example, in a recent experiment I did, I was getting users to turn light switch on and off. For example, it's a very niche experiment, but I promise there was a really good use for it. But I can do complex tasks like I can pick up objects. These actually have, if you can see on the side, grip sensors. So I can touch, I can grip, I can lift up, I can manipulate and hold an object. So it allows the users to point at areas in the virtual scene. So it facilitates some point and click. So again, I can point with this, press a button, and do something. So this has facilitated things like teleportation. So one way I can move around my virtual scene now is I can point at something, I can pull a button, and I will teleport there. Now, this has been great for cyber sickness because suddenly we have a control. Remember earlier I said that there's, with an acceleration, if you feel like you're moving in the virtual space, that can bring on feelings of cyber sickness. Suddenly we get away with that. We don't actually have to transition between point A and point B. We literally press a button and we're there instantly. So we've taken the movement out of movement. Now, this can be really, really useful in certain kinds of games. One of the challenges we have with teleportation is it doesn't feel real. Now, there are some games that potentially facilitate it. If you're playing as a futuristic bandit or something like that, then suddenly teleportation might make a lot of sense. But again, there's a quality that we're going for in VR games called immersion. And it's quite hard to get immersed in a role when you don't believe the movement, when you don't believe this is how I get from A to B, this is how I do that, this is how I progress forwards. Teleportation, for example, might work in a really futuristic game, but may not work in something more old-fashioned, like, for example, a medieval simulation. If you're going back in, again, I can use these quite successfully to swing a sword or a battle axe or use a shield, and there's lots of games that do that, by the way. But if I have the ability to teleport, why would I be using a sword and a shield? Why wouldn't I be pulling out my ray gun and using that instead? It feels disconnected from what we're actually doing. So what is VR movement? In this section, I'm going to talk a little bit about specifically how we approach motion in VR and what that motion looks like and how we integrate that into games. So for a paper that myself and a colleague did called Movement Modalities in Virtual Reality, which much of this presentation comes from, we define 4 basic types of movement along an axis of freedom versus physicality. So freedom is the how much you can move around the virtual space, and physicality is about how much you can move around in the physical space, if that makes sense. How much you can actually move and walk. And we define 4 different types. The most basic of which is a turret system, where the player is fixed in a specific location but can look around. In fact, a lot of mobile VR applications are seated. We can't really track people. But the idea in a turret system, think of it like a turret in a tank. You can rotate, you can look up and down, but you are locked into that one position. In the real world, you're sat on your chair. In the physical world, so in the virtual world, you are, let's say, you just have those 2 axes: rotation, elevation. Something that gives you a little bit more movement is a pilot system. In that, you are still locked in the physical world, but in the virtual world, you have a lot more freedom. You're able to. The reason we call it a pilot system: think of a pilot in a plane. You're sat in a chair. You have a fixed kind of physical location, but your control of the plane dictates how you move around. So a good pilot system example would be a virtual reality racing game where you're sat in a seat, you're not moving in the seat, you have a wheel, you can steer, you can turn, you can do all kinds of movement, but that's basically what you're limited to. And I will say, if anybody has any questions, please post them in the chat. If you're on YouTube, there should be a live chat window. Post them up there. I will try and answer them if I see them. The next stage up is what we call a motion system, which is very similar to a turret approach. That the player is locked in a single location, but the player's position is also tracked. So what we can do is, so sometimes we call this room scale VR. So we have a single room, a single virtual room that is mapped to the physical room. We can move around that physical room, and then there's virtual reality movement in there as well. And at the top end, we have an avatar system. Now, in an avatar system, the player has full freedom of movement around the virtual environment without concerns as to the boundaries of the physical world. So in theory, in an avatar system, again, for any Star Trek fans, think of this as a holodeck. We have a relatively small room, maybe. We're not concerned about the boundaries. We are doing things to allow people to fully move around the virtual space, regardless of the limitations of so move around the virtual space without regarding the limits of the physical space. So turret systems. Turret systems are great. Some of the first VR motion tracked examples. Some of the first games that we saw, and for anybody who's into their history of virtual reality commercial VR, Eve Gunjack was one of the very first really successful games, and this was a turret system. For anybody who's familiar, you might have heard of gaze shooters. Now, a gaze shooter means wherever you move your head, the VR headset is tracked, and you can shoot basically based on where you're looking. Again, speaking to my fellow geeks and nerds out there, think of Cyclops in the X-Men. You look at something, you shoot. Okay? Gaze shooters. It shoots based on your gaze. Movement in the virtual space is very typically limited to the head. Now, there are some examples of that. So some examples where that isn't quite the case, where they've given you slightly more movement. There are some where there's some comments. So Matt says, just on the previous topic, is hand tracking any close to being mainstream commonplace? Yes, and I will talk about that in a couple of slides. I'll bring that up in a second. And also, kind of nice guitars, Chris. Yes, worryingly, they seem to be multiplying. There's a new one just sat behind me right now, so I won't get it out. Nobody wants to hear me play. Pilot systems. So user locked in a single location, but their virtual representation is able to feebly explore the environment. We have two main varieties of pilot systems. We have what we call a continuous pilot system, which is where, again, think of me with a steering wheel being able to drive around the virtual environment. My movement is continuous. I'm constantly seeing movement going on. And a discrete system. Well, discrete should be in bold as well. Sorry about that. Formatting error. In a discrete system, you hop between places. So the user is able to jump or teleport around the environment. So we can jump from one location to another. Teleportation is typically how this is implemented. Motion, where the user is locked within one. Oh, sorry, I meant to say on this actually. I forgot. Two of the things that we've got up here, we've got this thing that looks like a big salad bowl that somebody sat in. We've been affectionately referring to as the salad spinner, your VR. It's this chair which gives you a feeling of movement, but you're essentially still sat in one physical location. And there's a slightly more advanced version of it on the right. We've got both of these systems at Lincoln. And again, this can give you more of a feeling of movement. And again, there is actually some evidence that can help reduce cyber sickness because we can now simulate inertia, we can simulate deceleration, acceleration, momentum, and we can give the body some sense that they are actually moving in that space. I think in this example where in the salad spinner is rotating from left to right, sorry, the your VR, shouldn't really call it the salad spinner. I think he's playing a flying game at the moment, so he's banking a plane. And again, that does feel like you're moving. So for some people, that is enough to trick their brain into believing that they are actually flying. And again, so we have done some really cool experiments actually with flight simulators. And there are some where, the way that the motion is synchronized, when you do a loop, there's a second where you feel like you're upside down. You're not. You're still sat in exactly the same physical location, but the combination of the visual and feeling that motion is enough to trick your brain for some people. So motion systems usually is locked within one defined physical space, but able to freely move within it. Their position is tracked and mapped onto the virtual representation. We sometimes call this room scale. Room scale, why? Because it is in the scale of a room. You can move within a virtual space within a virtual room. Some excellent games in this category. This was probably the biggest jump forward we had in commercial VR. Recent year was when the Steam VR came up with the Lighthouse tracking system, which is what this is based on, where we basically use two infrared beacons to track a user's motion in a physical space. It allows for some really unique, and you get rid of all those kind of, you get rid of a lot of those cyber sickness worries because suddenly we're actually tracking people's real movement. So if you're walking from A to B, you are actually walking. Your physical body walks, your virtual body walks. And that was a really great way to approach this. Really, really popular. And it allowed for a lot of new types of games to be developed that hadn't come along before. Really good example of this. If you want to have a look, see Superhot VR. Superhot is basically a combat game, which in virtuality became really, really good. And the way that they used room scale was just fantastic. So avatar systems. Now, this is the next stage forward. But I do think it is unlikely that we will see full home-based systems of these in the near future, at least, because they are very, very complicated. But we are starting to see some really exciting research in these domains. So in an avatar system, the user is able to freely move around the virtual environment while physically moving in the real world. So we kind of fudge this at the moment. So we have done some examples of avatar systems virtually, where we've combined a pilot system with a room scale system. So a pilot system with a motion system. And the way we do that is you move around a virtual room, and then you press a button to teleport into the next room. So you have freedom of motion. You have freedom to move around, but you're doing it by combining a discrete motion system with room scale. The way this is going, and as these two kind of GIFs show, is this thing at the bottom, this one down here, is called an omnidirectional treadmill. You have basically a set of bands that go in one direction and a set of bands that go around in another direction. That means that user can walk in any direction on that treadmill. So you can walk forwards, you can walk to the side, you can walk diagonally. And there's a really good example here where the user is walking diagonally. And the way that works is we track the user's motion and we adjust the treadmill to kind of always keep them in the center. And actually, if you look around, see this ring here, that was around the user, the player. That is what's there tracking their position to make sure they're always locked in the center. You combine that with virtuality, and in theory, you can walk entirely around a virtual space. And this is when we get much closer to. One day, I'm going to write a lecture called "Building a Holodeck." Now, how to build a holodeck. Again, this is very specific for Star Trek fans. It says Star Wars, crikey. It's very for Star Trek fans. But holodecks, this is one way that we could do it with an omnidirectional treadmill. There's also a robotics implementation of this, and I think these are really, really exciting. If we look at this example in the top right, what we essentially have is 4 robots with movable platforms, and as the user starts to walk, the robots adjust and create new floor underneath them. And the user is constantly, if you notice there, as soon as this step, they are being brought back to the center of the room. So in theory, we can walk freely around the virtual space. We can fully explore to our heart's content, but we'll always be brought back to the middle. So we are not bound by the limits of the physical world. And again, I know this is singing out to Star Trek fans most. This is a really interesting way. This is a way that we really could get that kind of whole holodeck feel, because suddenly we can do things like steps. And you'll notice as the GIF progresses, we have an implementation where the user is actually stepping up. So why are we unlikely to see home-based commercial implementations of these? One, these are super expensive. These are really, really expensive pieces of research equipment. And they require, despite being essentially locked in one space, they require a lot of space to set up. For example, the omnidirectional treadmill is obviously a big piece of kit. There's not a lot of people that have that amount of space that they can just dedicate to a VR simulation rig. The robots takes even more space. You've essentially got 4 or more. I think there's 6 in the main example. Synchronized virtual Rumbas, right, which you're walking on through the virtual world. And that takes up huge amounts of physical space. And the cost is astronomical. That really, really is an expensive approach. So the amount of users, and again, when we see commercial solutions, there's always this this trade-off. The more people you can sell it to, the cheaper it becomes. As a general rule, your margins can become much smaller. The amount of people who could justify buying this would be very, very small. Ergo, the costs are very, very high. The mass production is not really an option. So it is very unlikely to see that we'll see home implementations of these in the near future. And actually, that's one of the main reasons why we've only had virtual reality relatively recently. Virtual reality has been around since the early 80s, late 70s. But the cost was huge, really, really huge, and it required huge amounts of space. And it's taken a long time and technology to be developed in other areas, specifically mobile phone technology, that has allowed us to develop these kind of home-based solutions. Something I want to talk about briefly is motion simulation. And then there's something based on... right, okay. Actually, I'll go back to Matt's comment. I'm just going to flip back a few slides. On the previous topic, is hand tracking any closer to being mainstream commonplace? So we could argue it is commonplace now. Most modern VR kit as it's released, so I'm thinking things like the Quest and the new kind of VR headsets that are coming out, do hand tracking. So we're seeing a lot of hand tracking out there. There are commercial hand tracking options such as the Leap Motion, name nearly escaped me there, which do a really good version of hand tracking. So yes, I would say it is actually pretty commonplace now in virtual reality. The question is whether it's going to become more mainstream in other applications. And the reality is, I don't necessarily need to be using VR to use these. But we haven't really seen many examples of other applications of hand tracking outside of VR. Partly because it doesn't necessarily make sense. So if you think about it, in virtual reality, if I look down, I see my hands, and I can move my hands relatively independently of my head. If I'm doing something over here at the side of my head, I have the opportunity to look, see what my hand is doing, and look back. In a desktop version, if we're looking on a monitor, really we need some sort of wraparound system to get that same kind of degree of control. So for some, hand tracking doesn't necessarily make sense in all applications, but we are starting to see more things. We are starting to see applications where we do physically manipulate. I mean, certain training simulators come really to mind there. And actually, commercial level hand tracking became popular before commercial VR, and actually a lot of the early experiments were trying to combine the two. Another question: what do you find more important for a good experience, or even more conductive for learning VR? Better graphics or better physical motion control tactile feedback? Where should devs focus? This is a really interesting question. And the reality is both. It's hard to say one or the other. Actually, no, let me approach that from a slightly different angle. Right. So graphics, if we're talking about photoreal graphics, so where we can actually look at someone, they look like a real person. There's not a huge amount of evidence that's really important in training simulations. And actually, a lot of training simulations scale really far back. They go into the serious game territory of trying to basically just do an interpretation of real rather than something that actually looks like the real world. And there's loads and loads of examples of that. In fact, low poly VR is so popular partly because it allows you to maintain high speed, high fidelity. One of the problems we have with graphics, VR is moving mobile. The best selling VR kit out there, the most popular VR kit, is the mobile stuff. Things like the Quest, before that, the Gear VR, where you just slid your phone in because it's cheap, it's accessible. You don't need a dedicated kind of VR dungeon to play in that. Christmas, back when we can have people around the house. If you're playing a fun game, you can go, here, grandma, try that. You don't necessarily need to have this whole dedicated suite. It's more accessible. It's easier to use. However, with mobile, we have a lot more limitations on graphics and rendering. So, specifically the speed that we can draw new scenes. As that gets slower, as we get sort of lower FPS, suddenly the environment feels slightly jittery. There's higher latency. That makes people feel very, very ill. There's some fantastic examples of this, which I always think are close to torture, actually, where there were some examples where people had a monitor, a VR headset, basically, with a camera on the front, and they were delaying what people were seeing by half a second. And it was making people feel awfully, awfully ill. So we need to keep that rendering those graphics as fast as we can, and we often sacrifice graphics for that. But generally, the feedback is it doesn't matter. As long as what you're doing is a representation of what you're trying to simulate, it's fine. So, an example of this, we did some wheelchair simulation, wheelchair training, and we went really into the serious games route. So better graphics as faster graphics. The faster the FPS, the better, really. The better rendering, the more accurate the rendering. Super. Accuracy is important. Realism isn't necessarily that important. Whereas motion control and tactile feedback, I think are probably much more important from a user experience at the moment. The ability to pick things up, to manipulate, to do interesting things in that space, really, really valuable, really, really important. And that's what we're likely to see more and more of. Again, I do think this is just one stage of evolution. I think we're not far from looking at just tracking our actual hands and not needing any of this kind of accessory. And there's some really good experiments in there. And again, if enemies have played with a Kinect, you can do some of that stuff now. For me, that'll be the next evolution. Is really really good, really really good tracking. There hasn't been many examples of tracking, for example, legs, hips. If in addition to this, we're able to track legs and hips, we could have games where you're able to kick things, where you're able to jump in the virtual space. At the moment, that doesn't really work. There have been some really good examples where people have taken these and strapped them to their legs. And again, if you want, just look on YouTube. There's some really funny examples of that. But I think where devs are focusing on the moment is more and more accurate tactile feedback and motion control and motion recognition. In fact, modern systems like the Quest don't require the lighthouses that I talked about earlier. They use a camera and they track the room, and they do what they would call inside-out tracking. So I'll move on. Motion simulation. And I'm just going to give a slight nod to one of my colleagues, Ben Williams, because some of this is taken from an existing presentation that we did a few weeks ago. Ben Williams is doing some really fantastic work, specifically on those motion simulation chairs I talked about earlier, the yaw and the slightly more complicated chair, and he's looking into things like cyber sickness as part of his research. So by all means, do have a look at the work we're doing. Search my name. That we've got a number of papers out there that you might find interesting to read. So early motion simulation wasn't linked to virtual representations. Probably everybody has been on a kiddie ride at some point. You know, the things outside Tesco's, you put in 50p or whatever, and you get much like this. I don't know who this character. I don't watch SpongeBob. I don't know who this character is called. Maybe somebody can tell me. Tell me in the comments, who is this starfish fellow in shorts? So we have things like kiddie rides. We have carousels. So if anybody's been on an old kind of Victorian style carousel, goes round, the horses go up and down, gives you the feeling of being in a trot on a horse. And we see early examples in training. So the Link Trainer was a flying simulator, which was literally controlled physically with baffles and gave people the feeling of flying. And they could simulate certain types of... Ben's jumped in. Didn't realise you watched Ben. Patrick Starr, thank you. Don't watch SpongeBob. I searched for kiddie ride GIF, and this is what came up. So a flight trainer. There's an example of this locally in the Lincoln Air Museum. So by all means, go have a look. The Link trainer is really, really interesting. But this is an example of motion simulation before we had the computers to power it. So really, really interesting. Motion simulators have existed long before virtual reality. Before virtual reality was a gleam in somebody's eye. And we have early games controllers. So motion simulation is possibly best thought of as a category of tactile force feedback. For anybody who's old enough to remember, one of the first commercial examples of this, in fact, I think the first commercial example of this was the Rumble Pack, released in 1997 with the N64. It was basically a cartridge you dropped into the bottom, and the pad rumbled. You shot a gun, and the pad would go. Brrr. You know, you were driving, and you would feel some vibrations. It was limited by today's sense. And again, if you've used modern Xbox or PlayStation controls that have that kind of tactile feedback built in, nothing compared to that. It was a big vibrating thing. It served a purpose, but it wasn't particularly accurate. But the day it was revolutionary. Everybody wanted to have a Rumble Pack with their N64, and it made playing GoldenEye, for anybody who remembers the original GoldenEye game, revolutionary. We can use basic rumble, basic tactile feedback to provide some indication of motion. So again, think of driving over cobbles. You feel a duh, 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 duh as you go. We can do that with rumble. We just trigger that motion intermittently. Duh, 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 duh. So I have a feeling of that. We can do things with waves. We can actually send waveforms of motion, so you feel peaks and troughs. There's been some interesting examples using this for stuff like, for example, if a floor is collapsing underneath you, you can shake and then stop, and that gives you a sense of motion. It's not, you're not necessarily simulating the motion, but you're giving people the indication of motion. But this is really where it comes from. What we're essentially talking is we have synchronized from the game world to the controller an actuator response. So something happens in the virtual world, we try our best to do something about it in the physical world to recreate that. So what is motion simulation? We use real motion in the physical environment to simulate movement in the virtual space. So an example of this is pitching backwards to simulate acceleration. If we're in a car and you stand on the accelerator, you shoot back into your chair. Okay? So we can simulate that. Think about going over a roller coaster. We can do the pitching as we're going up the I don't know what they call the first bit of the roller coaster that towers you into the air, ready to plummet to your doom. And then we can accelerate by throwing you back. We can brake by throwing you forwards. So motion simulators are typically aligned to a vehicle. They're synchronized with a vehicle in the virtual space. So what we do is we track what that vehicle is doing. We track its motion, its acceleration, its inertia, and its acceleration in all axes, so left, right, backwards, forwards. We try and recreate that to give a feeling of motion. Why bother? Why should we bother with motion simulation? Again, I've talked about big and expensive. This is exactly what these chairs are. Adding sensory modalities can add definition and fidelity to a virtual environment. So what I mean by that is if we have additional sensors engaged, it feels like that virtual environment has more to it. It's got a crunch. It's got some sort of physicality, something tangible that we connect to. It improves immersion. We have quite a lot of evidence that says motion simulation can improve immersion, again, because it feels right. You feel the motion. There's evidence that this can be used to combat motion sickness. Cyber sickness. Sorry, not motion sickness. Cyber sickness. Sorry, that's wrong. By aligning motion with what you can get is motion sickness. So we have one colleague who I won't mention by names, who gets very sick on this kind of thing without virtuality because the motion, the tilting, the twisting makes them feel very poorly. Another reason we might want to do this is it's fun. These simulators are great fun. And again, with things like the Your VR, this is really accessible. It's cheap by comparison. It costs about the same amount as a high-end computer. It's small. You can fold it away into all the bits on it, fold back into the salad bowl. So you can reuse, you can store this under a desk or, in a garage or somewhere. You can take it apart, put it back together really, really easily. But it's fun. It's engaging. And why would we not want more of that? So as an example of this, this is me doing, we did a series in Lincoln called Star in VR. And you can see, this is me, ever so slightly heavier. I think it's just after Christmas. Driving the virtual car in the snow, pitching and rolling and rotating. And you can see, hopefully, that the movements in the virtual... I keep pointing over here because that's where it's on my screen. Pointing over here. How the virtual motion is changing my physical position. So as you see, I went off there and the whole chair kind of wobbled. Accessible. I talked about one of the challenges with some of these technologies is about how accessible they are. Traditionally, these are large, expensive, and heavy, and they require specialist technicians to use. This is one example. I would argue this is more of a giant robot with a chair attached to it than a motion simulator. Because and it's a debate that me and Ben have quite often. At what point does motion simulation just become motion? In this, we can actually recreate quite a lot of real world motion and line it almost perfectly one to one with the virtual space. Um, but this, you're talking millions and millions of pounds to create this kind of thing. And these are industry level systems used for training. Again, they have these at NASA for doing astronaut training. But we are starting to see cheaper consumer level systems emerging. The basic system, like the OVR, can be bought for just over £1,000. So, like I say, about the same price as a high spec computer. And some motion can be simulated through shop feedback. So, I talked about the Rumble, and we're starting to see things like Rumble chairs. I mean, they were actually quite popular in kind of the early 2000s, late 90s. A chair that essentially had speakers in them that you get a vibration. Again, if you're driving that car, you'd feel the motion of the engine and things like that. We're starting to see very simple, very cheap things that you can sit on a chair, even sort of like seat pads that you can sit on that will give you some sense of motion. So we're probably going to see more and more and more of this. At the moment, there's no consistency between systems. Again, I'm sure Ben will say in the comments, it's the bane of his life that all of these have different kind of interface approaches, different ways of communicating with them. So it's actually very hard to create a consistent experience. If I created a game where I wanted to facilitate motion control, it's hard to guarantee that different users will have the same experience. Because again, if you're sat on that Rumble chair, you're obviously going to have a very different experience to being on this giant robotic arm thing. But there are things that we can do, and we will start seeing more of that change as we go down the line. I think we're going to start seeing a lot more accessible motion simulators. In the same way that when the Rumble Pack first came out for the N64, it didn't really work with a lot of games. It didn't really do much because people weren't writing specifically to make use of that, because you had to assume that most people didn't have that. So you want to make that game accessible for everyone, so you don't write it where you need the Rumble Pack. So we didn't really see a lot of interesting things. And again, if you're playing a game where I've seen games, for example, where you don't actually have a visualization on the screen, you're feeling it all through input through the controller, we potentially have some interesting challenges there. What if somebody doesn't have that sensory modality? What if they don't have a control that gives vibrations? Suddenly they can't play the game. So is it in a game developer's interest to work in that way? We're going to start seeing a lot more of this as we get down the line. So what else can we do? There are lots of ways that we can feel movement. So I know there's a bit of delay on this, so I won't ask you to ask, but look at ask you to give me an answer. Look at the two images. How are these people feeling movement? Beyond the car, they've also got the wind in their face. They've also got the wind through their hair. They still have hair. I don't, but I still feel wind in my face. That is a different way that we can feel motion. Again, if we run or if we're walking on a windy day, we feel, all the time little sensors in our skin pick up on that information. They communicate it back to us. So we feel motion in a lot more different ways than just through inner ear kind of feeling like we're moving somewhere. So what we can do, we can start simulating that wind. And we're starting to do research in this area at Lincoln. We've been using big fans to simulate that sensation. And actually what we see is a reduction in cyber sickness. Now, there is a question about what's causing that. We're not saying it's necessarily the sensation of motion, but if you're feeling sick, cool breeze in your face can make you feel less sick. So we need to look at some things that isolate out those variables and actually figure out what's going on there. But there is evidence that simulating wind synchronized with motion does have some impact on reducing cyber sickness. So we might start seeing more things like this. And again, this is potentially a lot more accessible than a big motion chair. Again, I can potentially go to my latest game store limited and buy a fan system that plugs into my games. Go into virtual reality, I just stick the fan on my desk, it blows in my face. Fantastic. Done. I don't need the complex motion simulation process. It doesn't take up a lot of space. It's cheap because it's just a fan. It's accessible to me as a consumer. So I think we'll start seeing a lot more of these. And there is already a commercial solution out there. So if you want to know more, my email's on the screen. I'm Dr. Chris Headland. Again, I'm School Director of Teaching and Learning School of Computer Science. If you want to have a look on about any more about this, at the top, I've put a link to a previous lecture that me and Ben did on, which is specifically about motion simulation and the future of virtual reality. Below that, there's the paper that we wrote on movement modalities. So if you're doing it in research, or if you're interested in dissertation into VR, that might be a really useful paper. Another paper that Ben led on, which was exploring visual-haptic congruency in virtual reality. So we talked about earlier, synchronizing joysticks. So if you're playing a flying game, you see a virtual joystick, you feel a physical joystick. What happens if we change the joystick to a yoke or a steering wheel? Does that change how people, how immersed people are, how engaged people are? And if there's any last questions, please ask them now. Please feel to jump in. I'll do my best to answer. The final paper is one led by one of my ex-MSc students, a thematic approach to combating site sickness using airflow feedback. And again, we had some really positive results from that. I'm not seeing any questions, so I'll just take this opportunity to say there is a whole week of Science Week talks. Have a look at the link below. Go to the link website /home/socks/computer science week 2021. There's loads of really great talks there. And I'm sure they'll all be archived on YouTube as well. So do check them out. Other than that, have a fantastic day. Enjoy the rest of Science Week, and I'll speak to you all soon.